Hello, calculus fans. Now remember, a derivative is a limit. Sometimes limits don't exist. And so that idea is going to lead us to the next definition. We're going to say that a function is differentiable at x equals a if f prime of a exists, which means that the limit that generates that exists. The function is differentiable on an open interval, which could be an infinite interval, if it is differentiable at every number in that interval. So as an example, let's try to determine where is the function f of x equals absolute value of x differentiable. I think it's worth noting that we can rewrite the absolute value this way. So we can rewrite it as a piecewise defined function. Now when x is positive, we know that the absolute value of x is equal to x. And as long as h is sufficiently small, and remember, we can pick the h to be as small as we like, x plus h is going to be positive, which means x plus h in absolute value is just equal to x plus h. So that means when x is bigger than 0, we can say that f prime of x, which is the limit as h goes to 0 of the absolute value of x plus h minus absolute value of x all over h, we can actually just drop those absolute values, and we end up with a limit as h goes to 0 of h over h. And that just gives us 1. What that tells us is that f of x is differentiable for any value of x that is bigger than 0. Not only that, but we know what the derivative is. The derivative is 1. Now, our derivative, which starts out looking the same, we have to replace those absolute values with the same thing, but this time with a minus sign included. And so this time we get a limit of negative h over h, and so our answer now is negative 1. Okay, so that tells us that the function is differentiable when x is less than 0. Now let's see what happens at 0. So at 0, we have to consider the limit of f of 0 plus h minus f of 0 all over h. And now we'll put things into the function, and we get limit of absolute value of 0 plus h minus 0 all over h, if the limit exists. Let's go ahead and compute left and right hand limits separately. So the right hand limit, we end up with an absolute value of h over h. Since it's a right hand limit, we can remove the absolute value because the values of h that we're interested, they're positive. So we get a limit of 1. Now, what happens when we take a left hand limit? So we start out the same, but now when we want to get rid of the absolute value, we end up with a negative h over h. And so now we're going to get negative 1 as an answer. So that's a right-hand limit and a left-hand limit, one of which is 1, one of which is negative 1. They do not agree, so f prime of 0 does not exist. So the conclusion that I think we can reach is that the function is differentiable everywhere except at x equals 0. We can even write down a formula for f prime of x. It looks like 1 when x is bigger than 0, and it looks like negative 1 if x is less than 0. Let's look at the pictures of f of x and f prime of x. Keep in mind that f prime of x is not even defined when x is equal to 0. That tells us that the function f of x is not differentiable at x equals 0. Okay, here's the pictures. So we have the absolute value function, which is this nice v shape, and then we have f prime, f prime kind of reminds me a little bit of the Heaviside function. It's not exactly right. Heaviside function was at least defined at 0, and it also didn't go down to -1, but it's pretty close. That's something to keep in mind. Okay, that's all for now.